All right, you're welcome back again. And we are continuing from where we stopped. We want to look at another parametric test called MANOVA. MANOVA is otherwise known as multivariate analysis of variance. It's uh, higher analysis over ANOVA. When we talk about MANOVA, it actually expands upon the concept of analysis of ANOVA, which is analysis of variance, by considering situations where there are multiple response variables. When I say response variable, I mean dependent variables. So I wanted to take note of those statements, those terms, as I use them interchangeably here. Response variables are known as dependent variables. Okay? Now, MANOVA allows you to explore whether significant difference exists between groups or factors, otherwise called the independent variables. The groups or factors are called independent variables across a combination of dependent variables. In this case now, you're having a particular factor. All right. This particular independent variable here is categorical variable in a very simple term. Okay. It's called categorical variable in a very simple term. Right. Any particular variable is a factor. Okay. Oh, I hope you understand that. That's why you always factor it so that it can work appropriately. And at the same time, they are groups because they have many groups, 2, 3, 4, and more groups. For ANOVA, you have two groups or two or more groups, right? Okay, so but under one categorical variable. So you have to understand that this is what we are talking about. It's very simple. If you understand the concept of ANOVA, you can just transfer it here. All right, we are looking at groups in the categorical variable. We're also looking at which otherwise known as factors, or we call it independent variable, or we call it categorical variable. All right. In your data set, you have categorical variable there, which are known as independent variable, and we also have other continuous uh, variable which are called dependent variables. Here we call this one response variables here. All right. Dependent variable are called response variables. All right. Against factors. Okay. Okay. Let's go gradually. It comes in handy now in situation where where there are multiple response variables. Okay, where there are multiple response variables that need to be tested simultaneously on independent variable. You have multiple response variables. What are the multiple response variables I'm talking about? Dependent variables, right? That need to be tested simultaneously on independent variable, which has multiple groups. It has multiple groups, maybe 3 groups, 4 groups, depends. All right. So there are many other questions MANOVA help you to answer apart from this I mentioned. It helps us to address some questions such as how do different wing configurations in aircraft designs impact factors such as structural strength, weight, and aerodynamic efficiency. Now, the uh, different wing configurations here is a factor variable, or groups. All right, take note of that. Then we have a structural strength, we have weight, we have aerodynamic efficiency, we have 3 response variables, or otherwise known as independent variables. Don't forget, this is called dependent variable, okay? Different wing configuration. So you can have different groups, okay? Configuration A, configuration B, configuration C, depending what is called, all right? Now here we now have a response variables here. Okay, so this one, this different wings is called dependent variable, otherwise called groups or factors. Okay, now this particular uh, structural strength, weight, aerodynamic efficiency, they are called response variables or otherwise called independent variables. So simple like that. So let's continue. In semiconductor manufacturing processes, do changes in temperature, pressure, and chemical composition significantly affect outcomes like yield, reliability, and performance? You can see that. That's another example. Okay, that's another example. You can see another set of dependent variable and independent variable coming out there again, right? Again, are there notable differences in certain car characteristics, such as fuel efficiency or safety rating based on the country or of manufacture? Are there notable differences in certain car characteristics, such as fuel efficiency, safety ratings? Of course, these are mentioned as so far. These ones are called response variable. Okay. Notable difference in certain car characteristics. So, do various flower species exhibit statistically significant difference in measurement, such as sepal, petal length, and width? So we of course here we already have your group here. This is groups or factor, which is called dependent variable. Okay, and we now having your sepal, petal length, and width as well response variable or independent variables. So you understand the concept is as easy as that. So just understand those concepts first, then before you go into application. Though MANOVA in R won't tell us which group differs from the rest. Okay, we want to know which group differs actually, but it won't tell us. But that is easy to determine via a post hoc test with LDA, linear discriminant analysis, or ANOVA. All right, we see how to use ANOVA to do that very easily. All right, so as we will expect, MANOVA statistical test has many strict assumptions, including multivariate normality, linearity, in addition to homogeneity of variance and independent observations. All right, but let us look at a few of them. We have multivariate and normality. It says each combination of independent or dependent variables should have a multivariate normal distribution. This time around, we're looking at a multivariate normality check now, not just normal one we do before. Okay, this one is multivariate because we're dealing with what? Multivariate analysis. So take note of that. Homogeneity of variance also is important. The variance covariance matrix of the dependent variable is equal across groups, because now there are now many now, right? Assumption of independence. The observation within and between groups are mutually independent, which is seems to be accurate or already correct. So no outliers. There shouldn't be any extreme outliers in the dependent variable. There may be one or two, but it shouldn't be extreme. It shouldn't be too many. Then you need to remove them. Okay. So these assumptions are very important to ensure the validity, accuracy, and reliability of the MANOVA analysis and results. Though all the assumptions are not necessarily need to be met, okay? Like I told us before earlier, parametric test is robust, all right? Especially if you have a large sample size, okay? It's robust. You don't need to meet all the assumptions. If your sample size is large, you don't need to meet all the assumptions. If you can meet two, it's okay. You can still proceed to parametric test. You don't need to meet all the assumptions, but at least you must have a large sample size, right? So that, and make sure that the outliers are taken care of, especially if you are many. So you have to take care of them. So then you can continue. All right. So here we need at least two continuous dependent variables, When I say continuous, I'm talking about uh, a response variable. Now I'm trying to use statistical language that you are aware of, okay, before, so that you can blend with it here. Continuous variables, continuous variables, of course, right? Do you still remember? Yeah, normal response variables now, right? Measurable variables in your data set, right? Which we call dependent variables. Okay. We also have categorical variables with two or more groups to demonstrate the test, right? Which we call independent variable, all right? So take note of that. Uh, Anything missing? Let me check. Let me see if anything is missing before we continue. Yeah, okay, that's correct. Nothing is missing. So we'll just check to see if I miss something. All right, let's continue. Here, so like I said before, here we need at least two continuous dependent variables and a categorical variable which is called independent variable. All right, I will just put here independent. All right, okay. You don't forget that these factors, okay, these factor or groups, okay. Of course, this one you have many groups inside, right? With two or more groups, okay, to demonstrate their test, okay. Now here we will use inbuilt data set called erase. Okay, this inbuilt erase. Data set is always a challenge when it comes to this kind of testing. It's a challenge, so we don't have data set like that to see, but at least there are several data sets you can use. Okay, if you have your data set that meets their requirements, you can just slot in. All right, so we just load this called data erase to be loaded. So it's loaded now. Let us glimpse it and look at it, see what is inside. So we have rows, 150 rows, and 5 columns. We have separate length, separate width, separate petal length, petal width, and we have species. Okay, species have 3 groups. How do I know? It's very simple. Before we go for further, you can just table. All right. It's just type erase dollar species, right? So species. Let's look at the groups. All right. We have 1, 2, 3. Okay, 3 groups. 50, 50, 50 each in each group. Okay, 50 observation in each group. So this is equal length now. This absorption is part of the what we are talking about now. Equal Ferrous group. All right. Now that's done. So if it's not equal, that is unbalanced. So we need to use other method to tackle your problem. There are always a way out. So here, MANOVA will help us to analyze how now before I go further, don't forget these are now response variables. Okay, these are response variables. Separate length, separate width, petal length. They are separate. So we have 4 here, 4 response variables. Okay, you can use all the 4. You can, if they meet, all of them meet the assumptions, we can use all of them. At least to help us to analyze better. So then against the species here, species, which is a 3 groups. The species is 3 groups, okay, which is called factors. Can you see here? Factors. already been factored already. So if we are adding your any factor, we have to factor it by ourselves, but it's already factored, so we don't need to factor it anymore. So this factor variable, otherwise called groups or categorical variable, or otherwise called what? Independent variable. So take note of those languages. I use them interchangeably so that you understand properly what I'm talking about. So it's not difficult. So here, MANOVA will help us now to analyze how different flower species, which is the factor, okay, you see, the factor or independent variable, collectively influence multiple leaf measurements. You can see measurements such as sepal, petal length, and width, which are called dependent variable or response variables. Let me put it here, or response, so that at least once we understand properly what we are doing. Okay, so response variables. So these are response variable or dependent variables. Okay, how different flower species. Okay, we have species. We have 3 species here. 1, 2, 3. Okay, which is what I call factors. Okay, or collectively influence multiple how it influence multiple leaf measurements. Okay, what will be the influence of these factors or flower species on this leaf measurement? That's what you are looking at now. Okay. Okay. So question we can now develop a question maybe in a very simple way. We want to know if there is any significant difference in sepal, petal length, and width between different species. If there's any significant difference, so that will help us to see the effect. All right. So now because MANOVA uses more than one dependent variable. Okay, use more than one. When I say dependent variable, okay, you understand what I'm talking about now, so you won't be confused. All right. The null and the alternative hypothesis are slightly changed, not like other ones like ANOVA. No. In this case now, we have to tilt it slightly. How? Each null becomes, you can say that the group mean factors are the same for all groups or factors, or they don't differ significantly. All right. Alternative says at least, don't forget, at least one of the group mean factors is different from the rest. At least one. So if one is different, it will be significant. We'll see that as we go further. But you don't need all to be different for it to be significant. If one is different, it's significant. You discover that one different uh, factor can make it significant, while others are not. Right? Later, you can now further investigate using pairwise method to know which one among them that cause the significance, which one among them make it significant. You can now see the pairwise. So that will be done later using post hoc method, right? So now let us go further. Now we want to first look at let us plot and see. I want to plot each of the species. Okay, using ggplot. Let's run this guy. Okay, so that we want to put it together in one place. Let's call it a sepal length. Let's call it SA. All right, so you want to combine it together later. The first one is a sepal length. You want to plot sepal length. Okay, x-axis. Then sepal, species x-axis. The sepal length is a y-axis. Okay, that's our vertical axis. Okay, then we fill by species so that you can see the colors, different colors. So we want to a box plot. All right, make it the top. So let's run this one first. All right. Okay, that is done. Okay. So we run a sepal width as well, same way. All right. So just pull it one by one. We have done this several times, so you don't need to be confused with this. All right. So that's one petal width. This petal length, petal width. Okay. So just shorten it like that. So, all right. So now let's just use grid dot arrange. That comes from this particular grid extra, right? So help us arrange them and put them together instead of using flow, right? So you just call each of them here column. You have a number of columns 2, number of row 2, because there are 4, 2, 2, right? So just run this. So now it has come. So let's zoom it. Look at it. So this is what we are talking about. This is a species in color, okay? Setosa, color, and Virginica. So we have 3 species here for the flower, right? So this is sepal length, this sepal width, this petal length, this petal width. All right. So you can see their distribution here. This one have at least 1 outlier. This one has 2. This one has 2 here. All right. Here, this one has 3. This one has 1. This one has 2 here. So the outliers here is not that many. Is minimum. Okay, so it's not that extreme. So we can do away with that. So if you like, you can just remove it if you don't want, but at least it's not bad. So you can see their mean here. Okay, they have different mean, right? So it's very clear here that they have different mean. So this means the species for each response variable, you can see the effect of a species on this variable is a unique. You can see based on the mean, right? So that is what we are talking about. So when you just close this now, you can save it and use that. You can use that method for your maybe manuscript or thesis if you want. It's very good. So just need to label it, title it if you want. Then later, you don't need special legend for that. So one legend is enough for all of them, right? Like you can see here, one at the top here, it's enough. So all right, so let's go now. Let's try to check few assumptions before we go further. If it's only one that is, I think it's okay. So at least we just want to try that. So let's look at the normal assumptions, normality assumption rather. So we want to load this library called R statics, right? So that it can help us to do some perform some what they call it now. I think that should have not get here. I think Tidyverse could have handled that. Okay, so but we can just run this one to see. Want to see the groups, okay, for each of them, right? So we want to do this is Shapiro test, okay? This is different from Shapiro dot test. Take note. What I want to do is I want to do group Shapiro test here, right? That's why I loaded this guy, okay? So want to do Shapiro test underscore test. This is not Shapiro dot test. Take note. Normally when you use Shapiro, you use Shapiro dot test. That is different. All right. Look at this. See if I say Shapiro, for example, look at it dot test. It's not just passing your response variable here and run it one per one, but this is a group one now. Okay, this is different. That one is different. The one is down different. It's a group one. All right, it's a group one. So here we have our species. Okay, so that's a group by species. From erase, we have our each of the length measurement here, our response variables here. So we run this. Okay, let's see the result. All right, so look at it, species, variables, statistics. So let's see from here. Okay, from number 1, Setosa, we have this first the 1, 2, 3, 4, which is the first set for the Setosa alone. Then we have our statistic p-value. All right, don't forget this is our p-value. Right? So p-value is the one here. So p-value is here. It's not significant. Okay, it's not significant. So but for petal width is significant, highly significant for petal width. All right. So that means that petal width for Sentosa does not meet the assumptions. Okay, does not meet the condition for assumption. So that's what it means. But for the rest, they're okay. Apart from this one also, you can see this one also. It's also the same petal width also. beta width, the same beta width repeated here, which is also significant. 0.02 is smaller than 0.05. Take note of that. So, and I think others are okay, except no, that's all. That's all. So it's only beta width here. It's okay here, not it's okay. It meets assumption here, but here and here it fails. So the same beta width now is see one that is having challenge. So it means that the beta width can be eliminated from this experiment. You can eliminate it so that we just look at only beta length, sepal length, and sepal width. All right. So take note of that. So I'm just trying to show you step by step how you can run this. So let's go further. As the p-value is non-significant, p greater than 0.1 for each combination of independent and dependent variables, except for beta width. Okay, we fail to reject the null hypothesis and conclude that data follows univariate normality. This is univariate normality now because it's not yet group. Okay, it's not yet multi. Now what it means? Even though we group it together, I can do it together at once. Since separ.width failed the test, we can exclude it. All right, can be excluded. So let's now go further now and use what they call multivariate normality check. This multivariate now, you have to install this package called multivariate normal test. That is MV normal test package. You have to install it. All right. Do I've installed it, so I don't need to install anymore. All right. So I just connected it. So I just need to load it. Right. So I load it now. So I need to call Madia as a function. That's a function Madia. So I pass in my erase data set here. So because I want to use multiple this I make it a vector. So we have separ length, beta length, and separ width. So we have taken out the beta width out because it shows here that it does not meet assumption. So I have to take it out, right? So we have three left now, three response variables left, right? So we run this now. We run this now. We see the result here. Look at the result here. So we have a skewness and kurtosis. So these are statistics. You can see that this one say yes, this one say no. So here, p-value here is 0.002, right? Which is that's why it is no. Skewness does not meet the assumption for skewness, but it meets for kurtosis, right? Which is 0.2. So now, because one is okay, so we can continue with the test, even though the second one is not okay. So at least one is okay, so we can continue. All right. So as the p-value is not significant, p-value for kurtosis, we fail to reject the null hypothesis and conclude that the data follows multivariate normality. So we have checked, and they all make they are okay with a univariate except one which we excluded. We further tested again to see for multivariate, and we saw that one also is not meeting, which is skewness. So we didn't reject. We have to continue. All right. So that is that. Now let's now go ahead and perform our MANOVA test now that we have made our assumptions. So you can see check more assumptions, maybe probably on maybe variance and the rest. So you don't need to meet all of them, like I said before. You don't need to meet all of them. All right. So let's call it man. Okay, MANOVA. So shorten it to man. That's our variable name. Okay. So we call our function called MANOVA here. Okay. We pass our, because we want to do multiple, want to pass a multiple. So we column-bind. This is called column-bind. Okay, we column-bind it, this first, second, and third. All right. So we'll have been 1 to this for ANOVA, but these ones, we just want to pass it. So now our species is our data here. We post it here. That is our factor. All right, our group or particular variable. So our data is erased. So we run this line, which is assigned to man. So we now do a summary. The way we do summary for ANOVA, also we do summary for MANOVA here. So just run this. This is the result. All right. Using latrace. So we get the result is a highly significant here. You can see highly significant. So the residual is 147. So the degree of freedom is 2. You can see latrace is 1.13. So we can see that this is good, all right? So the p-value is practically zero. Yes, practically zero, all right? And which means we can safely reject the null hypothesis in the favor of the alternative one. At least one group mean factor differs from the rest. That's what it means. It means at least one group factor differ from the rest, but we don't know which one differ. It may be all of them, maybe one of them, that make it to be highly significant like this. But if it is highly significant, it means that probably might be all of them, all right? Because the physical nature is very high, might be all of them that differ. So that means all of them are significant. So let's check which of them is significant among them. So, but we do not know now which group may differ among the species. So using summary.ANOVA function, we can find which one differ among them. So let's check. We just pass our man here. All right, it is summary.ANOVA here. It's different from the one we used before. Okay, it's not the same. Okay, this is different. So we run this. So now let's look at it from here, from up here. Okay, we have these are response now, separate length. So species, this one is significant, all right? This one is this one differ, all right? You can see differ. Okay, response dot beta dot length. This one also differ. You can see highly significant. This one also differ. So three of them differ. So in some cases, it might be only one, but at this time around, three of them differ. So from the output above, it can be seen that all the four now, we are not using four now, we are using three now. Okay, all the three variables are highly significant, different among species. All right, because we drop one. All right, we drop one. So we don't even know. Maybe we'll have left the one also and see if it's able to affect the result. Right? Maybe we'll have left it, but you can try that in your own. Okay, you can try it. So we can further check the effect size. All right, we could measure the effect size. So what is size? What is the size of the effect? Because we are saying that this species is having effect on the response variables. That's what we discover here. That it's having effect on it. All right, because they differ significantly. All right. Now we can measure the effect size. So one metric often used with MANOVA is partial eta squared. It measures the effect the independent variable has on the dependent variables. Okay, it measures the effect that the species is having on the response variable. It's having on the measurements. All right, that's what we are trying to say. The effect is measure the effect. So if the value is 0.4 or greater, we can say that the effect size is large. If it's lower, then the effect size is very small. Okay, so this is the threshold. Okay, this is threshold. All right. So now take note. When we have to install the library called effect size. Okay, you have to download and install. Just install. All right. When you install, you can load it. So you now passing your man here. Don't forget our man here. MANOVA. We pass it in this one. We pass into the function eta square, right? So we run it. So if you're able to give us the effect. So when you run this now, you can see the effect. All right. Let's see. So this effect, right? Effect size for ANOVA type 1. So we have parameter. We have a species. Okay, what effect is it having on them? So we have the effect is 0.57. Okay, so look at it here. We have a very high. It's very high because our threshold is 0.14, and we have a 0.75 as a result. So it means the effect is greater. So its effect is large. So here the value is 0.57, which is very large. Therefore, we can conclude that yes, we can conclude that the independent variable has large. Let me just conclude that we can conclude that the dependent variable has large, which is species. Don't forget, the size is species has large effect on the three dependent variables, all right, or response variables, or on the measurements. All right. So that is our conclusion here. So you can understand, you can see the step by step we look at to perform MANOVA. MANOVA comes along with various components. That's what we look at individually. All right. I think this is very simple for you to follow, not difficult. What you need to understand is the concept of the parameters. I mean, the data set, the variables, or the columns you have in your data set, the concept, how to handle them. Understanding your data set is very important at this point. You must understand what you have, which one to use for this, which one to use for dependent, one for independent, and understand the terms as being used here: response variable, dependent variable, categorical variable, and the rest of them. You understand the terms as they are all being used interchangeably. All right. So just take note of that. So that is that for today under this section, and I think we see what to continue for this particular course as we have begun it, and we are going to be looking at also at a non-parametric test in the time to come. So thank you so much for listening. I will see you in the next class. So if you have not yet subscribed, you can go ahead and do that. And if you have a question, you can post it. You can like if you want. And I will see you in the next class. Thank you so much for enjoying the class. See you later.